chairmen and women to invite me to give a talk on that. I need also to apologize because it will be a synthesis and not a keynote. And the second apology is just I will focus only this morning on abiotic factors and not biotic factors that could decrease strongly the yield of legume in terms of pest and disease. And that is an important question in agronomy too. But I hope I will try to enlarge finally the conclusion to more generic conclusion than the presentation I will do on the synthesis of the effect of grain legume insertion in our cropping system in the southwest of France. So you can see all the colleagues that have contributed to this work. It's a work about, I must say, 15 years. It started with the nice grain legume integrated project that was granted by European Commission. So in our conditions in the southwest of France that you can see here, Portugal is just there. In the Garonne Valley in particular, it's devoted to arable crop production, both in rain-fed and irrigated system. The traditional crop rotation in rain-fed system is wheat, I mean durum wheat and sunflower. And then in that system, we have a very long fallow period between two main crops. I mean, just the time to have a baby. So farmers apply in that system high-end fertilization rate on durum wheat, more than 2,000 kilograms per hectare most of the time, for having high protein content, for having high quality, for technological aspects such as making semolia and pasta. So all the zone is declared in nitrate-sensitive area for nitrate pollution. And then we need to improve our practices in order to avoid this pollution. The other key point at the moment in France, at the whole France, is that we have a strong plan to reduce the use of pesticides. We have a very, very challenging objective aim to decrease by half the use of pesticide. And of course, you know that legumes could be a pillar towards the paradigm of agroecology. So I will, according to that context, I will explain the work we have done. So the inclusion of legume in arable cropping system represent apparently a good strategy to reduce current and fertilizer, the reduce greenhouse gases emissions at the cropping system level, local level, but also at the global scale level, I mean, considering the human diet, that is also an important question. So crop diversification with legume, or including legume, also contribute to a range of ecosystem services. And then according to that, we want to design prototypes of cropping system in order to give the best value as possible of the use of legume in such cropping system. So I will focus my talk on three main questions this morning. Which are the impact of the increase in the use of grain legume in the arable rotation, managed, and the conventional tillage on agronomic performances at the cropping system scale, not at the crop scale only, on the soil organic carbon and nitrogen, and on N2O emission, which is, a great gas for the impact on climate change. The second key question I will address this morning is, which is the role played by the concomitant insertion of cover crop in a legume-based arable cropping system on the key processes, in particular on nitrogen recycling. You will see in the talk that, to me, and this is one of the key points of the take-home message, in our system, we absolutely need to introduce concomitantly cover crop with legume in order to have a very good system functioning. The third point is intercropping an efficient solution to insert legume in these low-input cropping systems? So according to that, We have started in the framework of the GLIP Grain Legume Integrated Project, so a few years ago, an experimental cropping system with the experimental design that you can see here. So it is located at INRA experimental station near Toulouse. We had a split plot design, and you have the characteristic. You will have the talk after for the details. So we have compared three main rotation. The first one is sorghum, sunflower, durum wheat, without any legumes. The second is sunflower, winter wheat, durum wheat. And the third one is soybean, spring wheat, durum wheat. Of course, we have adapted all the management practices according to this rotation. I mean, the soil tillage, the use of input, etc., etc. So you can see that in sometimes there are a large period of bare soil. I mean the soil without any crop uptaking water, nitrogen, or nutrients. So in that situation, the probability to have a loss of nitrate is quite high when the rainfall is very high in winter, which is not always the case in our climate, which is quite variable according to the years. So in that conditions, we have also made two successive rotations, so two times of 3 years, so we have run the experimentation for 6 years, and also we have added 3 other prototypes of cropping system, including as much as possible cover crop. I mean crops that are not harvested, that are returning completely to the soil when it's possible, when we have the time to grow cover crops. And then we have 3 more prototype of cropping system. So at the end, we have 6 cropping systems. The 3 without cover crops, the 3 with cover crops. And of course, we have adapted the management practices. This is not an orthogonal comparison. Okay? So in that case, we have worked for 6 years. And after 6 years, we have changed the rotation. We have changed for reaching the target of decreasing strongly the use of pesticides. And then we redesigned the system in order to reach this objective. And in particular, we have also modified the name of the system. The first one is the low pesticide. This means that in the reference rotation we have in the experiment before, we tried to reduce by half the use of pesticide on sorghum, sunflower, durum wheat at the rotation level, not necessary for each crop. And then we compare with another rotation because we did not have so much and so good result with winter pea. We have changed with faba bean in order to introduce a crop we thought more resistant to pests and disease. And we have built a new prototype called agroecology, where we have grown only a mixture of crops, cash crop I mean. So sunflower, soybean, durum wheat pea, and winter wheat faba bean in mixture in both crops. So what I need also to say is that in the very low input rotation, we have grown all the monocrop, soy crop, as a mixture of 3 or 4 varieties with the hope to decrease strongly the use of fungicides. Of course, in that case, we have also maintained 3 other prototypes, including the cover crops. And in that case, we have made as much as possible mixture between legume, forage legume, and another families. So that is the experiment we have done, and we have done for 6 years, 2 successive rotation of 3 years. So we have a 12 rotation cumulative effect that could be analyzed. So in that case, we have nice design of mixture, and these design are not the same. For example, we have made experiment before to know what is the best design. I mean, do we need to grow in row or mixing in the row? For example, for soybean, sunflower, the more efficient solution for having the capture of light, the use of water and nitrogen is to have 2 rows of sunflower, 4 rows of soybean, etc., etc. In there are other words, for durum wheat winter pea, it's mixed on the row. No problem, you can sow in the soil, it's very easy, and it's functioning very well. The other point I want to mention very briefly is that we have, as I say, we have adapted the crop management on decision rules to adapt technical act, notably to water use or an application to the soil, but also for pest and management, pest and disease management, for crop status, etc. The second key point is that we try to, in order to make a strong diagnosis and as much as possible quantitative diagnosis, we did some plant and crop and soil sampling and analysis, biomass yield, but also N uptake, N2 fixation by legumes, water content in the soil at different periods of times, and also the soil organic carbon and nitrogen. So we have a broad range of data that we can use to analyze the system. The other point is that on the last 6 years, we have done measurement of greenhouse gases emissions, in particular N2O and CO2, but I will focus on N2O there. And we have a system with automatic chamber and spectrometer functioning in the field. So we are in the true conditions. You can see that we can put the chamber inside the cover and the canopy, between 2 rows, or when the row is too narrow, with the whole system. So we have some nice results about the nitrogen, the water, and the carbon cycle that we can analyze. And because it's not possible to measure all the N fluxes, for example, water fluxes in such experiment, it will be too heavy, even if we have some lysimeter. We have also used a soil crop model in order to get a more complete database. I mean, to get and to calculate some fluxes that we did not measure. For example, nitrate leaching, because you need to have water drainage and also nitrate concentration. It's easy to measure nitrate concentration in lysimeter, but you are not sure that they are giving you correctly the water drainage, etc., etc. We can have simulation of ammonia losses that were not measured in our system. So the model, I don't have any time to go into details, has been evaluated for in the last 15 years with a review of this evaluation in environmental modeling and software last year. And we have modified and improved the model recently in order to be not too crazy when we want to simulate N2O emission. That is very important not to be too crazy when we want to simulate something. So what are the main results? The 5 take-home message from our experiment. And after I will enlarge what could be generic, what is not. Nice picture, sunflower, soybean. So the first result concerning the N balance and the N predicting effect of grain legume, it's a very, very well-known result. So, of course, when we are growing grain legume in such arable cropping system, you are decreasing the amount of fertilizer that you need at the rotation scale also. For example, by comparing 0 with 1 grain legume, we decrease by half at the rotation level the use of fertilizer, etc. So you know that very well. But when we insert cover crop in our system in order to avoid nitrate leaching, we had a small problem is that this cover crop lead to net N immobilization of nitrogen in the soil. And then this is a preemptive competition in the dry years. I mean that when there is no leaching, there is no loss. You have cover crop taking the nitrate in the soil. It releases a part of the nitrate, but not all the nitrate, because a great part is going in the organic matter. So you have a preemptive competition effect. In that case, to reach the same yield, you need to increase the fertilizer. That's also an example of what is the adaptation of the management we need in such a system. We have recently published this result with Daniel Plaza-Bonilla, and you can see the yield here of durum wheat as an example that was more or less the same. This means that we have quite well adapted the management of the system in order to take into account the preceding effect and so all the aspect around this preceding effect. We have also reduced the use of N fertilizer for this durum wheat. You can see here according to the system, and we have managed that carefully. So what are the main conclusions is that for durum wheat we have higher here durum wheat yield even if we have reduced the N fertilization. In that case, the difference is significant with the situation where the preceding crop was the sunflower. Even if we have increased here, you can see the N fertilization. So the rate of N fertilization must be slightly increased after cover crop also, in some case for the preemptive competition effect, but not necessarily each year. It depends if you had before strong leaching or not. So this example is also valuable for fababine for the experiment after. As a preceding crop, we have more or less a reduction in our situation of 45 kilograms per hectare. This is the save off. And also, concomitantly, even if we decrease the N fertilization, we have an increase in the production of the sunflower of 8%. Not necessarily for the durum wheat, but for the sunflower. The second point I want to mention is the effect on the N cycle. First of all, I would like to convince you that the soil seed crop model is a relevant crop, even imperfect, to simulate water, carbon, and nitrogen cycle. So here it's just an idea of what we can simulate, and you can see that there are no bias for the simulation in our experiment of the biomass of the green yield for the different crops you have: durum wheat, mustard which is grown in cover crop, winter pea, sunflower, veg-oat. Just example to show you that the model is robust, can simulate a wide range of situation. Also for the N accurate, I mean the N content in the crop at the harvest, and also for the N2 fixation, I mean at harvest or during the crop cycle. So we use the model to calculate the nitrate leaching. So here you have 9 plots, because I did not say it before, because we have three crops. Each year we are growing the 3 crops. So this means that each year we have the 3 rotation, but not starting with the same crop. It's very important when you have climate variability. If not, if you don't do that, you could have very strong result, because the weather it changes so importantly in our conditions. So this means that we have the 3 rotation with each 1, 2, 3, and starting with here the sunflower, starting here with the durum wheat, and starting here with it was starting with the sorghum and the sunflower. And you can see that this is the cumulative nitrate leaching for the 6th year. You can see that at the end we had 22 kilograms of nitrogen that was lost in in rotation without any legume, until 52 kilograms of nitrogen per hectare in the situation with 2 legumes. I remain soybean, spring pea, durum wheat. So I mean, even if we have decreased the N fertilization and adapt, we have more nitrate leaching. So it's very well known, just a new demonstration in our condition. The other fact is that by the inclusion of cover crops, this nitrate leaching surplus due to legume was completely eradicated. We have only between 15 to 20 kilograms per hectare, which is very low amount, because we are also in very low input farming systems. So the second take-home message is that yes, nitrate leaching simulated with the model was higher when increasing the number of grain legume after 2 rotation of 6 years. The other key point I want also to mention concern the soil organic content stock in the soil. Because I read many things on that, and in our condition, unfortunately, we did not find the same result than our colleagues. Here is the rotation without any grain legume 1 and 2. You can see a sharp and dramatic decrease of the soil organic content in 6 years. We have the same result for 12 years. This means that when you are introducing such grain legume in our system, in our pedoclimatic conditions, we have a decrease of the soil organic matter. Why? Simply because we have a decrease in the carbon we are integrated in the soil, because the quantity of the residues that you are incorporating in the soil is lower, simply because legumes have less biomass production than cereal production in our condition, because we are fertilizing cereals. And okay, so inserting grain legume in the rotation significantly affected the amount of carbon and also nitrogen. It's coupled. Input in the soil that were lower than with cereal, and consequently lead to a decrease in soil organic carbon and also N content in our conditions. So what's happened with the cover crop? With the cover crop, you are introducing more carbon in the soil, more nitrogen, because you are recycling, and then you are recalibrating the input of carbon and nitrogen. And then in that condition, you could have an increase, not significant here, when even without the grain legume, but in that situation, the decrease of soil organic carbon is completely avoided. So this is a way to stabilize the system. The benefits of cover crop grain legume is also true for the soil organic carbon. Decrease with in bare soil, stabilize with cover crop. The other point is that grain legume also, this explained by the fact that grain legume take nitrogen in the soil, but also have N2 fixation. And then when you have a cover crop in the system, when there is residual mineral nitrogen, which could be high, you can see after winter pea, spring pea in November, you can decrease this mineral nitrogen with cover crops. Here you can see. And in that condition, you can recycle better the system. So you have nice result on durum wheat. So, however, cover crop insertion in that system reduce enriching, mitigate soil organic loss and nitrogen loss, and did not affect durum wheat grain legumes. So this is a good solution. The fourth point I want to mention concerns the N2 emission with legumes. So we have compared here in the last 6 years the low input system with the very low input system, including, as you can see here, so farbabine, here, farbabine, instead of sorghum. So N2 emissions were low in our system, less than 1.2 kilogram of nitrogen per hectare and per year. But N2 emission during the farbabine crop was lower than other crop because we did not add any fertilizer. But N2 emission after farbabine were higher than after cereal and sunflower. At the rotation level, finally, N2 emission was significantly higher with farbabine, even if the level is low and significant higher. Fortunately, because we have saved fertilizer, the indirect emissions are lower. So at the balance, the N2 balance, it's okay. Just want to say that we have modeled the N2 emission in order to see if this result could be representative of a whole piece of work. So we have done some validation of the STIX model. I don't have the time to go into details, but we have done the job for 3 Mediterranean environment, a very high water deficit in Senes in Spain, medium water deficit in Salverana in Spain, and in a low water deficit in Ozeville in Toulouse. And you show, we have compared different rotation, that in Spain, where there is a high water deficit, the N2 emissions are very, very low. In Ozeville, they are higher and more variable according to time because of the weather variability according to year. So in that case, we don't have the time to go into details. We don't have any differences between the rotation with or without including P in the cereal-based rotation. What the main explaining factor, the main explaining factor was, yes, the main explaining factor was the water deficit. So this is a key point in our system, and also for when we want to spread some result of N2 emission to the world. We need to take care about that. So daily measurement of N2 emission over the whole 3-year rotation were low, but significantly higher when we have had it favorable in our condition. Fortunately, indirect N2 emissions are lower. So the global scale is in favor of legume. What about money? In our system, without grain legume, I don't want to go into details. We have calculated the semi-net margin for the 3 years in euro per hectare. So you have the basis without grain legume. Here you have the result with the first grain legume, winter pea included in the rotation, and here with soybean and spring pea. So you can smile. That's good in our situation for the business or for the profitability. Just some of the key messages dealing with legume insertion in cropping system. First of all, as I have mentioned, we have introduced legume in the cover crop. To our conclusion, we need to mix legume and another crop in order to have the best ecosystem services together of nitrate capture and grain legume, nitrogen manuring. I mean, save nitrogen from niching and release nitrogen for the next crop. We need to mix. It's also efficient for nitrate leaching. You can see that mixture gives the same nitrate concentration or more or less the same than non-legume cover crop. So that's a very nice solution. We also have done some work on grain legume intercropping with many results with different collects. I just want to mention that in low input system, not in a productive system with high input. And in organic farming, we have shown with different collects that the productivity in the term of global grain produce, cereal plus legume, is higher of more or less 30% in organic farming in a synthesis we have done, which is very important for increasing the productivity in organic farming. Some conclusion. Considering the main results in such conventional tillage system, properly designed cropping system need to simultaneously insert grain legume and cover crop, including legume, for all the reasons I have indicated. The 6-acre model or other model well parameterized and validated could be a relevant tool for doing a more quantitative multi-criteria analysis. Mixture species, legume and non-legume, is an efficient way to improve the system in low input and organic farming system. And for improving various ecosystem services, cover crop need to be composed of a mixture, including legume. One another point which is very important is that if you use crucifera, some crucifera could also have a biofumigation effect for biocontrol of some wheat and some soil-borne parameters, not pathogens, sorry. So towards innovative, sustainable cropping system, then our challenge now is to redesign our cropping system with more legume for providing multi-ecosystem services as a way of strong agroecology. But we need to change our paradigm. This paradigm needs to be changed at the field level, I must say cropping system level, but also at the territory level, see the keynote of Marie-Hélène, and at the whole agrochain level, see the talk of Marie-Benoît Marini. We need to unlock the system. Legume offer also a solution to attenuate climate change. We have some work in a project. I don't have the time to go thorough. But numerous factors still need to be optimized. Even if we have the best variety of the world, this variety will not function in all the systems, in all the situations. So we need to adapt that. So it's an agronomic tool. Agronomy is returning to the level we need to have for this challenge. And the last key message, it's just a message personal. Modeling is a relevant tool for exploration of scenarios. Relevant tool, this is not the only tool, but a very complementary and interesting tool. I would thank you for your attention and apologize for the time too long. Thank you.